In this video, we will review sections 13 and 14. So as always, take your time. We got a domain problem, and then we got a whole bunch of simplify. Okay. I'm going to jump right in. Finding the domain, all about the denominator. We don't want the denominator to equal 0, so we will set it equal to 0. X squared plus 5x minus 6 equals 0. Now I will factor. Minus 6 is my grouping number. Multiplies to 6, subtracts to 5. Be careful, folks. I picked this one in particular. It's very tempting to use 2 and 3 because 2 plus 3 equals 5, but the point is it needs to subtract. So it's 1 and 6, negative 1 and positive 6. X squared minus 1x plus 6x minus 6. X out, x minus 1. 6 out, x minus 1. X minus 1 in common, x plus 6 left behind. X minus 1 equals 0, x plus 6 equals 0. Well, x equals 1, and x equals negative 6. But again, these are the x's we want to throw out. So I take my number line. I've got negative 6 and positive 1 as the values I want to throw out. I want everything else. So here to here, I'm looking minus infinity to negative 6. Here to here, we're going negative 6 to 1. And then here to here, we're going from 1 to infinity. That would be the domain of this function. Number 1, now we're simplifying. Well, it's all about factoring. If I'm going to simplify 3x squared minus 17x minus 6 all over x squared minus 36, I'm looking to cancel the common factors. So I've got a factor. Well, the denominator, no big deal. A nice a minus b times a plus b. The numerator, a little more work. I'll just do a little work on the side here. I see a nice trinomial. I'm looking at the grouping number of 3 times negative 6 is negative 18. And right off the bat, what multiplies to 18 and subtracts to 17? Well, 18 and 1, specifically positive 1 and negative 18 to get a negative 17. So 3x squared plus x minus 18x minus 6. As I group, an x comes out, 3x plus 1 is left. Over here, a negative 6 will come out, 3x plus 1 left behind. Now, you could finish factoring here, but plenty of people are comfortable enough to just, okay, now that I'm right there, put my answer up here. The 3x plus 1 comes out, the x minus 6 is left behind, and I see matching x minus 6 is that cancel. Final answer, 3x plus 1 over x plus 6. Number 2, more simplifying, just more terms. Simplifying multiplication, technically top times top, bottom times bottom, but in reality, just more factoring and canceling. I'm now looking at x squared minus 9 over 2x plus 6 times 2x minus 5 over 12 minus 4x. And not too bad here. Most things are pretty nice. The x squared minus 9, that's a simple x minus 3, x plus 3. The 2 times 2x plus 6, a 2 can come out, x plus 3 left behind. 2x minus 5, hey, that doesn't factor. That just stays 2x minus 5. Here, this is again one of those tricky spots. It's easy to just take out the 4 and be left with 3 minus x. But then you got to realize you could eventually make those cancel. So this is where we've said in the irregular video, a lot of people would prefer to put this in better order, to make it a minus 4x plus 12. So now you're more tempted to take a minus 4 out. And when you take that minus 4 out, you're left with an x minus 3. I see x minus 3 cancels with x minus 3. I've also got an x plus 3 that cancels with an x plus 3. I'm left with a 2x minus 5 on top. And I'm left with 2 times minus 4, so a minus 8 on the bottom. Number 3, dividing. I'm automatically changing that to multiplication and flipping that. Before I even think about factoring, before I think about anything canceling, make it a multiplication problem. 2x squared plus 18x over 5x plus 10 times x cubed minus 64 over x squared plus 5x plus 36. And just notice, I mean, I had to make this one a multiplication, but after I did, I just see bigger terms here. Higher powers, bigger terms compared to what we just did a moment ago. So in that sense, it just makes me more inclined to do more work off on the side. That the 2x squared plus 18x, oh, that one's not bad. A 2x comes out and x plus 9 is left behind. The 5x plus 10, oh, that's pretty simple. A 5 comes out and x plus 2 is left behind. But over here, the x cubed minus 64, I need to see an a cubed minus b cubed. 64 is 4 cubed. A will be x. B will be 4. So this will become x minus 4 times x squared plus 4x plus 16. It went a minus b, and then a squared plus ab plus b squared. And let's get all that up here. Over the x squared plus 5x plus 36. Well, 1 times 36 plus 36 is my grouping number. I'm sorry, folks, that was supposed to be a minus. Sorry about that, folks. Make that a minus. Go back to the original. Sorry, make that a minus. So I'm sorry, that should be a minus 36. What multiplies to 36 and subtracts to 5? Well, 1 and 36. Nope, that subtracts to 35. 2 and 18. Nope, that subtracts to 16. 3 and 12, still not there, subtracts to 9. 4 and 9, there we go. That's the one that subtracts to 5. I need the positive 5, so a negative 4 and a positive 9. X squared minus 4x plus 9x plus 36. X out, x minus 4 left. What did I do wrong here? Oh, I'm sorry, folks. Again, geez, sorry. Again, that was a minus. 9 comes out. There's the matching x minus 4. Again, sorry, folks. That was a minus. So it's still a minus there. So x minus 4 out. X plus 9 left behind. Over here, x minus 4 times x plus 9. And now that we did all that factoring, now we could take advantage. We see a bunch that cancels. X minus 4 with x minus 4. X plus 9 with x plus 9. And that's it. I shouldn't say too much cancels. We still have quite a bit left. The singular terms, well, no, 2 and 5. Nothing happens there. X plus 2. Nope, nothing cancels there. So all that's left, 2x times x squared plus 4x plus 16 all over 5 times x plus 2. All right. Now we move to number 4. For number 4, we're looking at x minus 3 over x minus 4 minus x over x plus 4. Common denominator, already factored. My common denominator would be x minus 4 and x plus 4. This is missing the x plus 4. This is missing the x minus 4. That gives me a common denominator of x plus 4, x minus 4. On top, well, I got a bunch here. I got to multiply all this out. I've got an x squared. I've got a minus 3x. I've got a plus 4x. I've got a minus 12. I could combine this right here, or I could just keep going. I'll have a bunch of like terms. Don't lose the negative. A negative x times x minus x squared. A negative x times minus 4 plus 4x. I've got a positive x squared and a negative x squared. They cancel. Minus 3x plus 4x is 1x. 1x plus 4x is 5x. The minus 12 is still there. No like term, but it's still there. Over x plus 4, x minus 4. I take a moment. Can I factor that any further to maybe have something that cancels? Not here. 5x minus 12, nope, that's stuck. So that is as good as my answer is going to be. Next, number 5. Now we're doing an addition problem. 10x minus 2 over x squared plus 7x plus 6 plus 4 over x plus 6. I still need common denominator, but before I just jump and go x plus 6 over x plus 6 and x squared plus 7x plus 6 over x squared plus 7x plus 6, similar to what I did here, I need to realize that's not factored. So on the side, let's factor that. Grouping number 1 times 6 is positive 6. Multiplies to 6 and adds to 7. Well, it's 1 and 6. X squared plus 1x plus 6x plus 6. X out, x plus 1. 6 out, x plus 1. This just factored as x plus 1 times x plus 6. And that is my common denominator. This one is ready. This one is missing the x plus 1. So I've got the common x plus 1, x plus 6 for the denominator. Here, the 10x minus 2 just came down. Here, I've got 4 that needs to distribute. So I get 4 times x is 4x. 4 times 1 is 4. And at the end, that became a 14x plus 2 over x plus 1, x plus 6. Now, I still check to see if this could factor to eventually cancel. And technically, this would factor a little bit. A 2 could come out with a 7x plus 1. But ultimately, nothing cancels. So if you have that over that, that's fine. But it certainly could stay that over that for your final answer. Number 6. We're looking at 5 over x minus 2 over x squared over 3 over x squared plus 1 over x. Bit of a mess, but not that bad. Starting on top, 2 fractions needs to become 1. Same in the bottom, 2 fractions needs to become 1. Right now, common denominator. X squared is x times x. This is just missing an x. I'll do an x over an x. So I'll get 5x minus 2 over x squared. Down here, x squared is x times x. This one's missing the x. I get 3 plus x over x squared. One fraction divided by one fraction becomes that first fraction times the reciprocal of the second. I see matching x squareds that cancel. I'm left with 5x minus 2 over 3 plus x. Nothing more to be done. And now last but not least, number 7, we're looking at 1 over x plus 8 minus 1 over x over 16 over x cubed. Number 6, both top and bottom had 2 fractions. Both needed to be cleaned up. Number 7, it's just the top. The bottom is good, ready to go. It's 1 fraction. But the top, I'll do an x over x here and an x plus 8 over x plus 8 here. That's the common denominator, x times x plus 8, already factored. So I see they're both missing each other. So on top, I've got the x plus 8 for the common denominator. And I'm getting x here minus 1 being distributed. I get a minus x and a minus 8. That stays. Before I do my flip, I notice this can be cleaned up a little bit. The x and minus x cancels, so it's really just minus 8 over x plus 8 over the 16x cubed. 1 fraction divided by 1 fraction becomes that top fraction times the reciprocal. What cancels? What do we see? 1x cancels here with 1x here. 8 cancels with 16 with 2 left over. I've got minus times x squared. I've got a minus x squared over x plus 8 times 2, or 2x plus 8.